Okay, so I would like to introduce to you another way of doing row reduction, and that's using SympY. SympY is a module or library within Python, and Python is a very useful and widely used language. So I think it's more useful for you to get some experience with Python than to use Sage. So let me start with this tutorial. Look at the address here, docs.sympy.org/latest/tutorial/matrices.html. And you'll find on this page some example code that you can use to get started. So here it says run code block in SympY Live. So here you can take this code and run it in a server off the web. So let me run this code block. And these commands were already in SympY, in the SympY Live shell, which is the online version of SympY. We don't need to worry about these too much right now. The important thing is that in order to execute that code, all I did was click on the execute Python code, and I got these two statements. And I'm not going to explain these two right now. This just does something about the display of the results. Right. Now, I want to go down and do reduced row echelon. So if we go down here, we'll find an example of reduced row echelon. Down, 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 down. Now, the thing is, once you get the code in there, then you can modify it. All right, so here it says run code block in SympY Live. Let's do it. Here's my SympY Live. All right, so here's my code. You can see that my code is in there. I put my matrix M. So here's how I enter the enter the matrix, row by row, where each row. Sorry, it's still executing. Let's wait till it's done. So here we have matrix, enter matrix row by row, and this shows the matrix M, and it displays the rows, and then this takes the RREF. So you can see this very similar to how you did it in Python, how you did it in Sage, but this Python shell may be a little bit easier to work with. All right. So now suppose I want to row reduce a different matrix. I can just copy this here and put it here, and let me modify it. Suppose I want to do 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12. Okay. So you can see how to enter matrices in this way. So let me go down there. So if I print M here, it should show me the value of M. Okay. And then I can just do m.rref like this. And it will show me the RREF. Okay. Now, nice thing about this that we didn't have in Sage is I can use symbols, which was this stuff up here. SympY understands from these commands, it understands that XYZT are symbols, KMN are symbols that represent integers, and FGH are symbols that represent functions. So I can use this to do one of the problems in the target exercises that would be difficult to do in Sage as much as we know about Sage right now. Okay, I want to look at number 2 here. Consider a linear system whose augmented matrix is this. For what value of k will the system have no solutions? Now, if I try to put this into Sage, it's going to choke on this k. But I can put the k in to SympY because SympY understands that k represents a variable. So let me go back there. Now, the way SympY is set up here, k is an integer variable. It doesn't really matter in this case. All we care about is that it's a variable. So I'm going to go here and I'm going to create a matrix. So let me call the matrix A. Okay, and then I'm going to use this same form. Let's see what the matrix was. 1, 1, 3, 0. That's the first row. Second row, 1, 2, minus 5, 0. Third row, 8, 17, K, 1. Close, close, like this. That's A. And see, it doesn't show anything because I didn't ask it to show. Let me verify that my A looks correct. All right, now I can just do A dot REF like this. And here it gives me the RREF in terms of K. Right? So what I can notice from this is that the 1 over K plus 48 here. Now, if K is equal to if K is not equal to minus 48, then we have no problem. Then we can have a REF with 1 here, 1 here, 1 here. If K equals minus 48, we have a problem. This REF doesn't work. So in fact, that's the value of K for which the system has no solutions. What's happening here was in the row reduction process, in order to make this the leading one in the last row, it divided by K plus 48. But if K is equal to minus 48, you can't do that. So the answer to this question is K equals minus 48. Okay?